together. So it actually kind of works a different direction. I'll show you better in a minute. And then the next one's going to match up, and that one's going to be another valine. And then when it's done, it'll reach a stop codon. The stop codon will say, okay, we're done. By now, the chain of amino acids comes off the ribosome. It started folding and twisting and bending, and it comes out, finishes folding and twisting and bending, and it has its shape. Once it has its shape, it has a function. So when a protein is synthesized, it comes from the gene's instructions. The genes tell the cell, put valine first, put leucine next, put valine next, put threonine next, put branched chain amino acid, I can't think of one off the top of my head right now, put another amino acid, and then the amino acids in primary structures, just a chain of amino acids, is not functional. But when the functional groups on amino acids interact with each other, because some are positively charged partially and some of them are partially negatively charged, it becomes twisted and folded and attracted to itself. Once it folds and assumes a shape and is free of the ribosome, that's when you have a functional protein. So genes code for proteins. Genes code for chains of amino acids. Once the chain is built at the ribosome, it twists and bends and folds and assumes a shape. Then it becomes a functional protein. Okay? Okay. Now, we'll see a little movie about it, but let's put some more stuff up here just for fixing it. The turkey foot is called tRNA, which stands for transfer RNA, because it transfers the amino acids into place. This is your chef, okay? This is the recipe copy. This is the stove in the kitchen. This is the chef, putting all the ingredients in the pot, stirring it up, and putting it in the oven to bake, okay? The transfer RNA does the translating. It translates the mRNA codons, the mRNA, let's say one codon at a time, into a chain of amino acids. My stomach just kicked in. Said, okay, time for lunch. I'm pretty consistent. It's always at about the same time every day, isn't it? Okay. Primary structure of a protein is a chain of amino acids. That's what the gene codes for. Once the chain is made on the ribosome, so why does the shape of the protein make it determine its function? I'm never going to be a pro basketball player. I learned that many years ago. Just don't have the shape for it. In fact, when I was a kid, my mother's like, you should be a stewardess, because stewardesses were like the new hot career then. I couldn't be a stewardess. I wasn't tall enough. Stewardesses had to be a certain height in those days, and I didn't cut it. So, thank God, because I really don't enjoy flying that much. I think I'm going to die. And when you're flying over the Pacific Ocean, oh my God, you're like, I have absolutely no control over my fate right now. And if anything goes wrong with this plane, well, I'll probably die before I ever hit the water. Of fright. Yeah, flying to Asia or even Europe, I don't recommend it. Boating over there, probably not good either. That's what happened to the Titanic, and that was a big ship. Like, just stay where you are. Don't push your luck. Oh God, I like to be there, but getting there, oh, I hate that part of the trip. Anyway, and I don't drink anymore, so I have to tough it out. One time, my sister and I, when I first moved down here, and I was young and hot and crazy, and my sister is 10 years younger than me. She was crazy and hot also. So my sister came down here, and we took a cruise together to the Bahamas. And we were a little concerned about seasickness, so we bought Dramamine. Well, let me tell you, in those days when you bought Dramamine, that was some kick-ass shit. Nowadays, I don't know if it does anything, but in those days, it would knock you out, especially if you're on a cruise to the Bahamas and you're having cocktails too. So here's my sister, took our Dramamine, we're having cocktails on the ship, we're so wasted, and it's cold, and the ship is rocky, and it's rainy. And what do we have? Bikinis and beach towels. That's all we have in our backpack. So we take out the beach towels and we wrap them up like blankets, and we both fall asleep on a bench on the deck. Well, I don't know how much time went by. I woke up and I'm like, where is my sister? Where is my sister? So I thought, well, maybe she went back up to the bar. So here I stumble. It's rocky, and I'm wasted because I've been taking Dramamine and drinking, and I'm stumbling all over the deck, trying to make my way to the bar, get to the bar, can barely see, but I don't think my sister's there. Stumble all the way around the next level of the ship. I don't see my sister anywhere. Finally, give up, stumble back down to where I came from, sit down on the bench and look next to me, and there's my sister sitting the whole time under a beach towel. I don't know why I mentioned that, but
that was some good stuff.
So we get to the Bahamas, and I'm somewhat functional. My sister is not. She is out cold. So I have to like drag my sister off the ship, and I don't know if they still do it, but in those days they stopped you and you had to have a passport check.
Mm-hmm.
She wasn't even awake. They weren't dealing with it. They're like, you sober her up to do the passport check, or she can just sit there and rot. And it was kind of like a warehouse where we had to go.
Mm-hmm. Yeah.
Yeah, well, we sat there for several hours.
Oh.
Yeah, she was really shit-faced. That Dramamine did the job. We weren't seasick at all. In fact, we didn't even know we were on a boat. Okay, so functional protein with active site. So the gene codes for the chain of amino acids, but it's the functional protein that we're concerned with, and it becomes a functional protein when it assumes its shape. So what happens if I were to change one of the codons? Instead of having CAT, maybe I have CAC, or maybe I have CCC, or I have some other codon. I'm going to get a different amino acid, perhaps. If I get a different amino acid, it's the interaction of the amino acids that makes it twist and bend and fold into its shape. I'm going to get a different protein. So when you have a mutation in one letter of a codon or more letters of a codon, it's going to change your protein. That's what mutations are. A change in the letters results in a change in the protein. What if I get a change in a letter that ends up making the codon a stop codon? Then I'm going to get a break in my protein where there's no amino acid. And I'm going to have two fragments. That's what Anita was talking about. That's called a nonsense mutation. In your handouts package, there's a page of genetics and mutations before explained. A nonsense mutation is when a change in the genetic code results in no amino acid. A missense mutation is when a change in a letter results in a different amino acid. You get a different amino acid, you're going to get a different protein. So every different protein has a different primary structure, a different sequence of amino acids. If you change the order of the amino acids in the chain, you get a different protein. If I change one of the amino acids or more than one of the amino acids in the chain, you're going to get a different protein. Okay? So now you see how your genes determine your proteins? And most of what we are, and most of what bacterial cells are, is water. And after that, protein. Most of the genes code for proteins, because proteins build all our three-dimensional structures, and they also are our enzymes. Enzymes are proteins of tertiary structure. Remember that from yesterday? Sure you do. Enzymes are metabolically active proteins that run all of our metabolic reactions. So most of what we are is protein, and most of what we do is requiring protein. So that's why the genetic code is so important about proteins. Okay, I want to show you a little movie. So let's do that, and then somebody write down in your notes to remind me, you have to talk about the redundancy of the genetic code. And silent mutations.
Redundant unit, does it code from that one amino acid can have multiple codes?
Yeah. And I want to try to get this little flick going. Redundancy and silent. Okay, let me see if I can find this video. I have a couple of videos, but come on, computer.